going to be talking about absolute value equations and absolute value inequalities today. Has anybody ever solved absolute value equations or inequalities in here? Just curious. One person. You have? Wow. What?
Absolute value 6, 7.
Really? Absolute value equations and inequalities.
Not
Okay, well maybe this will be easy.
We didn't do inequality.
Okay, well let's see. Wow, okay, I didn't know that. The other class said no. All right, well, let's review how to solve, and we did this on the warm-up. I just want to make sure we're all on the same page here. We're going to solve this inequality. There's multiple ways. You can distribute. At this point, I think I would prefer just dividing by -3. It looks like it'll be simpler to solve. So I'm dividing by -3. It's an inequality. What has to happen here? Turn that sign. Now when I do my division, right, that's a 1, so it's just x plus 3, less than 0, right? Subtract the 3, x will be bigger than -3, yeah? And so how do we graph that on the number line? We say, okay, let's go to -3. We put this circle around it and we say, I want all the x's bigger than -3. So you kind of draw this line here, right? We all learned this in, I don't know, a couple of years ago probably. And what does that mean, an open circle, this hole here? What does that mean, Christian?
It's greater than or less than, but it's not equal to.
Yes. So it's not going to be -3. The last class somebody said, well, why don't you just do this instead? At -2, why don't you just put a filled-in circle at -2 and go that way? Isn't that the same thing? Jerry, is that the same thing?
No, because it counts for all real numbers too, and not just whole integers.
Awesome. Right? Integers, if we only cared about the integers, this would be correct. In between -2 and -3, we have an infinite number of real numbers, don't we? And we have to include them too. So -2.999. That's also a solution. So the circle just says not -3, but as close as you can get to -3 and not be -3. These will all be solutions. Nice. I like how you said real numbers and integers. Awesome. Okay, let's see what's going on with this one. This is an OR case. So what does this mean? So you solve each one of these separately. X bigger than or equal to 5. Subtract the -3. X less than or equal to -5. So what could x be? It could be any x that is bigger than 5, or it could be any x that is less than -5. These are all fair game for our solution. So what does that look like? You go to 5, which, well, I guess that's right here, and you say, okay, it's this way. And then you go, oh, it's a filled-in hole, thank you. Yes, it is a less than equal. I fill in the hole. Then I go to -5, and, draw my circle. It's an equal. So -5 is part of the solution set. And then I want to be less than, that's this way. Right? So the x's can be in here, any x that is smaller than -5, and any x that is bigger than 5, part of the solution set. Let's look at this guy here. Now, I don't know if you've seen this before. We've seen it a little bit. We used it when we looked at triangle sides, right? This is called a compound statement. You notice how this is an OR? This is an AND. So when you're done, it has to be true at the same time. And I'll show you what I mean. You're basically going to solve these at the same time. So if I'm going to subtract 2, I'm going to subtract 2 from this one, but I'm also going to subtract 2 from that one. So that becomes -25. Then 5x now, right, because we subtracted away that 2. And then when I divide by 5, I'm going to divide them both by the 5. So I have -5 less than x as less than or equal to, what am I talking about, 3? So what does this look like on the number line? What does this even mean? X is bigger than, right, because x is bigger than, the bigger part is by the x, the pointed by the -5. It's bigger than -5, and it is smaller than less than or equal to 3. Those two statements have to be true at the same time. They both must be true. That's an AND. So if I go to -5, that's an open circle. If I go to 3, that's a closed circle. And everything in between. What's this? Oops. So what is this saying? X is between -5 and 3 and includes 3. But it's not all the x's less than 3. If I took all the x's less than 3, it would be here too. But these x's aren't bigger than -5, so they don't qualify. And AND means they both must be true at the same time. Okay? This one is kind of a strange looking one. And if I try to solve this one, kind of strange things happen. If you add 3 to both sides, what's that, negative 12, 4x, negative 16? I can't add today. No, that's 15, sorry. No, I cannot add. Divide by 4, both sides, that's a negative 3, and this is whatever negative 15 over 4 is. But wait 1 second here. If I put this as a decimal, negative 3.75, and if you were to try to graph this, here's negative 3, here's negative 3.75. It says x has to be bigger than negative 3, and at the same time, it has to be smaller than this. Can I be those things at the same time? Can this be true at the same time? Can I find any x that is bigger than negative 3 and at the same time smaller than this number? Oh, God. What's happening here? If you look at this statement up here, I'm trying to see here. That's terrible. This is a negative 15. This is a negative 18. See these less thans? They have to be true. This thing has to be less than that thing. Negative 15 less than negative 18? No. Is it? No. So this is a crazy statement to begin with. So sometimes you have to be really careful about, you have to kind of get out of autopilot is my point here. That you've got to really pay attention. Yes, a lot of this is rote memorization. You're learning a process, but you always got to think about what's going on here. This one does not make sense. Yes, sir, Zane?
Is it number 2
This one? Well, the difference here is this is an or, and this is an and. When it's in between like that, it's an and. It says this could be true or this could be true. That can happen. They don't both have to be at the same time. So as long as you have an x that is smaller than this, or if that x is bigger than that, I'm fine. But this one says they have to be at the same time. It's a very subtle difference between the or and the and. When we used to do set notation, or meant union, and meant intersection. So if you know anything about sets, that may or may not help. But we don't teach sets anymore, we should. All right, getting down to absolute value. What is it? So absolute value 3 answers the question, what numbers are 3 away from 0? Jerry, what numbers are 3 away from 0? What?
When it says and, it has to be like this. Right?
Um,
It has to be inside.
Yeah, it does, doesn't it? Because then it's true for them at the same time. This can't be an and. They're not true at the same time. It doesn't work. Yeah. All right, getting back to this. Numbers that are 3 away from 0. Well, 3 is, right? And negative 3. So absolute value, and you know this, it's the distance from 0, right? And since it's a distance, it is a magnitude, which means it's just a positive number. How many away? Negative doesn't really apply here. So basically, we always say absolute value means take the positive value. It does, but because it's representing a distance. So here's how we say it in words. We say the distance a number is from 0. That's one way to describe absolute value. Another is to say the magnitude of a number. So negative 4, its magnitude is 4. So, what's kind of the important part of that? How big is it? So that's words. Here's the math way of saying it. This is a math definition of absolute value. For any real number x, so x is a real number, the absolute value of x is, and you may not have seen this notation, you have a little curly bracket here. Here's one rule. So the absolute value of x is x, if this condition is true. The x value you're looking at is bigger than or equal to 0, so a positive number or 0. If you have a number that is less than 0, you take negative x. So if you plug a 3 in here, that's this situation, it's 3. If you plug a negative 3 in here, that's less than 0, so take negative 3. So it's a mathematic way of saying just take positive. I want the positive value of that number. So math is kind of awesome. We're trying to count for all the different possible x's you could put in here. All right, so the mathematical definition of it. And let's just review this. What's the absolute value of 5? Absolute value of negative 5? 5. Now be careful here. What is this? You do the calculation inside first. What's negative 5 minus 1? Negative 6. Now take the absolute value, 6. People get confused here also. Do the calculation first. Negative 5 plus 1. So the absolute value is 4. It's not let's take the positive and add that at 6. Don't do that. So keep the negative, do the little calculation. Last thing you do is take that absolute value. Some confusion there sometimes. Alrighty. So that's stuff we know. Right? Right. So some of you say you know how to do this too. Solving an absolute value equation using algebra. So let's see. The rules are basically whatever you get, you want the absolute value expression on one side of the equation and anything that's not in the absolute value on the other. And there's two things you have to think about. Because if you have the absolute value of x equals some number, say, it could be that this number is a, right? This absolute value of a is a. But it could also be that you've got the negative version of that number, and you took the absolute value to make it positive. So that you have to think of two situations here. Sometimes there is no solution, and you really, 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 really have to check it. Now, when I taught Algebra 1, I said always check your solution. Everybody went, sure, right, yeah. And then hardly, I had a few people who did, most people didn't. You actually have to hear, because there's some tricky bits that could happen. So, yes, sir. Okay, then just let me finish, okay? Let me finish here. Alrighty, so looking at this one, this is the first one. What's the solution to this? Okay, and I'm going to ask you guys not to shout out, because I do want to give people think time. Some people are really, really fast, some people need a little think time. But this one, I hope we can see. If this is a 3 in here, that works. If you put a negative 3 in here, that also works. Do you have a question, Krishna? You could write plus or minus 3, sure. Okay, now here's the general way to do these. So if I give an absolute value of some expression equals a number, say, or whatever's on this side of the equal, you have to consider two situations. One situation is just take away the absolute value symbols. It could be that 2x minus 3 is 5, right? That's one situation. However, it could also be that whatever is in here comes out to negative 5, and you took its absolute value to get 5. So it could be that 2x minus 3 is negative 5. So there's two possibilities that you have to account for. So now you have two equations to solve. So let's solve them. Add 3 to the one on the, I'm doing this one first. Divide by 2. One possibility is x is 4. Here's the other situation that could be. Add the negative 3 here, add positive 3 rather. You get what, negative 2? So x is negative 1. You must check these. So take this 4 and plug it in. 2 times 4 is 8. 8 minus 3 is 5. Absolute value of 5 is 5. Works. Put in a negative 1. Let's see. 2 times negative 1, what did I do here? Is negative 2. Negative 2 minus 3 is negative 5. Take the absolute value, 5. So 2 solutions. 2 solutions. This is typical. Let's try the third one. So x minus 4 is 6. So we just said, here's the process. X minus 4 is negative 6. Or it could be that it's the opposite of that. And I would just be quiet, please. Add this one. Add that one. These are my solutions. Let's plug it in. So I put in a negative 2. Negative 2 minus 4 is negative 6. Absolute value would be 6. Oh, it doesn't match. Not that one. Put in the 2. 2 minus 4. Oh, that's not it. Wait a second. Yeah, I'm taking an absolute value of anything. Once I take it out, aren't I going to get a positive number? So Jerry, tell me why, because you've been champing at the bit here. What's the issue here? This is negative, right? If I take the absolute value, will I ever get a negative number? No. No. So before I even started, if I would have noticed that, I could have said, you can't do that. Absolute value will never be negative. Let me just make sure we can see that. I'm going to erase some of this mess here. Y'all see that? This is one of those things that, we're very used to. Let's follow a process. This one, you really got to think about it. The absolute value of a number is negative 6. Really? You're always going to have a positive value pop out. So no solutions. Yeah. The second one. Yeah. This one? Yeah. Okay, let's say it's 10. 10 minus 4 is 6. You get negative 6 when you take the absolute value. No. So I didn't even have to do this. I could have just saved myself a lot of time by actually thinking about it before you even start. Does it even make sense? No. And there's another way to express it. This was on the warm book. Some people have questions on what that is. This is a null symbol. It means the null set, which is the same as this, which also means the null set. It means what are the solutions? I have an empty set. There are no solutions. So if you've never seen that before, that is worth mentioning. All right, let's look at the fourth example. This is example B. All right, so part of this is it says isolate the absolute value. What does that mean? It means I don't want this 8 over here. Move it over. Because I want the absolute value symbol all by itself. Subtract 8. Wait, what do you mean? It doesn't work. Christian, what happened?
Absolute value can't be negative.
Absolute value can't be a negative. So some of you are already trained to kind of, now I know to look for it. So you have to kind of really think about, does this even make sense? I could save myself a whole bunch of time. No, there's no x that you can stick in there that will work because I will never get a negative output from the absolute value. Make sense? A little bit? All right, this guy here, you can have x's on both sides. So you follow the rules, the absolute value on one side, everything else on the other, and you do it kind of the same way. So the first thing you're going to examine is what if 3x plus 2 pops right out and it equals 4x plus 5. It could also be that the 3x plus 2 is really the negative of this value. So you have to be a little bit careful to say the negative of that whole thing. So notice how I put it in parentheses, because it's the negative of that whole thing. And these are the two equations I'm going to solve. I'm going to start here with one that looks a little easier. If I subtract 3x, right, don't I get x on this side? And if I subtract 5, I get a negative 3. I'm going to use the symmetric property of equality, turn it around. Let's try this side. You got to distribute that negative, which I am doing, so remember that becomes a minus as well. Add 4x, subtract 2, right, divide by 7. I've got two possibilities, let's try them out. So negative 3. If you plug negative 3 in here, you get 3 times negative 3, which is negative 9, plus 2 is negative 7. What's the absolute value of negative 7? 7. Let's plug the negative 3 here. 4 times negative 3 is negative 12. Negative 12 plus 5. Are these two things equal? So is this a solution? No. So I'm going to reject that. That doesn't work. Let's try negative 1. All right, so 3 times negative 1 is negative 3. And negative 3 plus 2 is negative 1. Take the absolute value and get 1. Let's plug the negative 1 in here. 4 times negative 1 is negative 4 plus 5. Oh, that one does work. 1 and 1. So I do have a solution, but only one. Only one of them works. That can happen. This is why this last statement here is so very important. You really have to check. Sometimes this happens. A hint, it is most likely to happen if there's an x over here, right? If you have some variables on this side here. That's when you're most likely to see that. So be cautious if you see something set up like that. I really, really, really got to check that both of them work. Maybe none of them work. Who knows? Okay. So what are we up to? We are now looking at inequalities. That's all you need to know about equations. So who has seen this before? Now that we kind of know what I'm talking about. You've seen this? Really? Who did this? Where'd you do this?
6, 7.
Math 6, 7, you do absolute value equations. Wow. And you did the stuff with no solutions? And okay. I did. Everybody in my first blog said, nope, never saw it. Everybody else in 6, 7, but not getting it. Yeah, okay. How about inequalities? You do those?
Yeah.
Does Miller do those? No. Okay. All right. Got one up in Miller now. So, just like any inequality, you solve them like equations, but you have to worry about the symbol. So we have to worry about the symbol a little bit more here. So you're going to do the same kind of things. The absolute value needs to be on one side of your inequality symbol, everything else on the other. But I've got kind of two situations. So there's two kinds of inequalities. You have greater than or less than. And I know it could be equal to, but I'm really just thinking about the inequality part of the statement. So if you have an absolute value that is greater than a number, this is the or situation. X could be bigger than A, or X could be less than negative A. Let's think about what I did here. So remember when there were equations, you had to look at the positive, and you had to look at the negative, so I'm doing that. But my sign will flip, my symbol flips. If you have absolute value of something is less than a constant here, or some value, some expression, it could be that x is less than a, and this is the and situation, x bigger than, change that symbol, negative a. So that's the and situation. Ors and ands, we looked at that. So let's just do a relatively simple example. This is on the top of page 2. You on the top of page 2? There are a lot of papers turning over. Okay, so what do you do? It's just like with the equations. So you say it could be that x minus 20 is bigger than 5. Or, why or? Because it's a greater than, that's an or. It could be that x minus 20, now I am going to look at the negative possibility, the sign, the symbol rather, turns. So it could be it's greater than this, or it's less than that. Yeah? So then you solve these inequalities. Let's see, x bigger than 25, or x less than, I'll say 15. I'll say the right thing. And that's your statement. X, if you were to graph this, x bigger than 25, all right, that goes here. Or x is less than 15, that goes here. So this is the or situation. Either one of these things, now I'll write it, I guess, the smaller one first. It's not that important, but okay, that's the or. Now this, I'm starting with the less than. This is an and situation. So you set it up the same way. You say x minus 3 less than or equal to 4, and, because it's a less than here, and x minus 3, return the symbol and negate what's over here. It is. It's a boundary situation. You're bounding something between two numbers here. You think about it, you will see that's what you're doing. Okay, so let's see what I got here. I can't see it. So I'm going to add 3. Yeah. So x less than or equal to 7, and x bigger than or equal to, I'm adding 3, negative 1. So let's think about this. X is less than or equal to 7, and at the same time, it has to be bigger than or equal to negative 1. Let's see if we can draw that. So you've got a negative 1, and you've got a 7. X is bigger or equal to, so I guess I gotta fill this in. Right, so that's going this way. And then I've got my 7 here, it's less than that. So basically, your values are in between and include negative 1 and 7. How do you write that? So you put the x here, see my less than or equal, that goes here. X is bigger than or equal to negative 1. I have to write it backwards. X is bigger than or equal to negative 1. If you read this right to left, see how the big part's towards the x, pointing bit to the negative 1, big part to the x, pointing bit to the negative 1. It's equivalent. This is how we write a compound and statement. Questions how we got there? Yes, sir? This one? Okay. If you have a greater than when you start, that's going to be an or. If you have a less than, it's going to be an and. And that's when you get to the point where it's absolute value and then something else.
But what if there's like, if x minus 10, we solve it first?
You make sure it looks like this. So like over here, put the 4 over, and then it's a less than, in case you have to do a division, you know what I mean? So you want to have the absolute value on the left. That's all you want on the left side. No other thing to do except deal with the absolute value, and then everything else on the right. Like for example, this one, move it over first, and I'm going to change this to x plus 3 just because I like it better that way. You don't have to. Now make a decision. So now I've isolated my absolute value, everything's else on the right. What do I have, a less than? So what's that? That's an and situation. Okay? So this one's going to be x plus 3 less than 4, and x plus 3, turn the symbol and negate this. And then we have to solve that thing. Yes, we do. So x less than 1, and x bigger than negative 7. So let's see what's happening now. Can we start to think about how can you write this without graphing it? So like the x goes here in the middle, and it's less than 1, but it's bigger than negative 7. So x is going to be between negative 7 and 1. These are less than, not including them, but everything else in between. Question? I saw a hand up. Anybody? We okay? Okay. I'm gonna skip D, do not worry about D. It's harder than it needs to be for where we are right now, so just cross out D. Skipping it. And we're gonna look at this guy, x plus 1 less than negative 6. So our rules were what? Oh yeah, you say x plus 1 less than negative 6. This is an and situation, right? X plus 1 bigger than positive 6. So this becomes x less than negative 7 and x bigger than 5. Well, what does that look like? So negative 7 and 5. X is less than that. And at the same time, it has to be bigger than 5. This is not an or. This is at the same time. Can you have any number at the same time be less than negative 7 and bigger than 5? Can that happen at the same time? No! This is saying what? No solution? What's happening? Let us go back now and put our brains back on. Let's look at this. When you have the absolute value of something, what always comes out? Positive number of some kind. Will it be less than this negative number ever? Like if here's negative 6, right? You take the absolute value, they're up here, right? It's saying, no, I want to know the things that are less than it. There aren't any. Does that make sense? This is really, you got to think about that. So if you can kind of see that ahead of time, wait a second. You can't take the absolute value and get it smaller than a negative number. It can't happen. No solution. Yes, sir? How do I get what? It's an and because it's a less than. Less thans are always ands. And greater thans are always ors. So, does not work, no solution. If you can do that, just take 2 seconds before you start a question. Is this one of those wacky things? You can save yourself a lot of time. Now let's look at this guy. This is F. Well, F is a different situation. Let's see. Can I have an absolute value be bigger than a negative? Of course, right? There are absolute value numbers bigger than a negative.
They'll always have.
Well, let's see. Let's do it. X plus 4 is bigger than negative 3. Now this is the or situation. Or x plus 4 is less than, right? Turn the symbol negative. So x would be bigger than negative 7. Or x would be less than negative 1. If I did that correctly, so let's think about if I graph this. And it's an or. Oh. So I go to, here's negative 1, and here's negative 7. X is bigger than negative 7. Here's where all the x's are bigger than negative 7. X is less than negative 1. Now this is not an and. They don't have to be at the same time. This says any x that is bigger than negative 7 and any x that is less than negative 1 is okay. So isn't that the whole number line?
Yes.
All real numbers. Now let's go back and look at the original thing here. How many, what numbers are going to be bigger than, what absolute values are going to be bigger than negative 3? Anything, right? Isn't this a positive number? And aren't all positive numbers bigger than negative 3? All real numbers. Anything. Any number you put in here will work. Okay, so now these cases here, I mean, they are kind of, this is really pushing the thinking cap thing. But that's okay. I want to push the thinking cap thing. I got a lot of people here considering algebra 2 or trig, yes? So I just want to make sure you're making the right decision. This should be cool. Who thinks, wow, that's pretty cool? Right? Good. So if you're signing up for algebra 2 trig, you're like, it's hard and it's making me a little bit anxious. So if you're feeling uncomfortable, it's just something to consider. This is actually from an algebra 2 trig class that I taught. I actually had to take stuff out to make it a little bit easier. So when I taught this, there was more in here. Let's see. All right, so we have some practice ones. Let's just talk about it. So I'm kind of sort of middle-ish of page 2, x minus 10. So let's kind of review now. We did the teaching. So when it's an equal, it could be that x minus 10 equals 6, or it could be that x minus 10 equals negative 6. Those are my 2 possibilities. So solve these 2 equations. X is 16, or x is 4. And those 2 possibilities, let's try 16 minus 10, 6. 4 minus 10 is negative 6. Take the absolute value, you've got 6. So there's my 2 solutions there. Same thing here. x plus 2, whoops, I don't need this guy, it equals 7, or it could be, or and it could be, I don't know what we want to say, or I guess, x plus 2 is negative 7, so x is 5, or it could be that x is negative 9, I do it right? And you can plug them into check, negative 9 plus 2, yep, 5 plus 2, check them. This one here, you always want to have the absolute value expression by itself. So I'm going to move that guy to the other side. So 3x minus 1 equals, let's see, 3 minus 5 is negative 2. All right, what's my next step? What's your next step? What? What did you say? You should? What did you say? Why is that no solution? Will my absolute value ever be negative? Oh, she just saved us all kinds of time, didn't she? Nice job there. No, definitely. She said, why don't I just think about it first before I plunge right in an autopilot? Any questions about, some people are shaking their heads, why is this not solution? Please ask if you're like, huh? What? I don't mind saying it. I want you to kind of see it too. I don't want you wasting time doing something you don't have to do, right? Yeah.
How do you get a negative value?
You can't, right? Well, I subtracted 5 here, right?
Yeah.
And 3 minus 5 is negative 2, and you're right. I will never get a negative when I take the absolute value of anything. That's why there isn't any solution to it.
But for like the one before, how can you get
This one, why did I do this? Okay, because it's an absolute value. So it could be that this thing is 7, right? That's how you get 7. But also the absolute value of negative 7 is 7. So x plus 2 could be 7, or x plus 2 could be this negative 7. So I have to kind of check both ways. Because isn't the absolute value of negative 7, 7? So we're checking both possibilities. Now think about it a little bit. All right, divide by 5 first. You always want this expression all by itself, the absolute value expression. It could be that x minus 2, the way I got 6 was it was 6. Or maybe, Bree, like x minus 2, when you worked it out, it came out to negative 6, which is okay because then I took the absolute value. So I'm checking both possibilities. X could be 8, or x could be what, negative 4? Those are like the equations here. Let's try this guy real quick. No, we got time. I don't even have to be quick. All right, so again, x minus 2, straight up, that could have been 2x minus 3. It could have been you got the negative of this value and then you took its absolute value. So it could have been that x minus 2 came out to the negative of 2x minus 3. And notice how that's in parentheses. That whole thing grouped together is negative. I got to solve these two things. Subtract this x and add that 3. X is 1. Okay. And then this one, x minus 2, 1's a weird number. Then 2x plus 3. Right? Because don't forget, you're distributing a negative. That becomes a 3x. And that becomes a, that's not that weird. Only 5/3. And now we want to check solutions. Plug the 1 in. 1 minus 2, well that's negative 1. Take its absolute value, you get 1. Put a 1 in here, you get 2 minus 3, negative 1. Are these things equal? No, this one doesn't work. We're going to reject this guy. 5/3. Oh. Yeah, you can use your calculator to help you out here. I think I got to do it again. So absolute value. If you're looking for it on the calculator, press the math button, move over to num. There's absolute, and just put in 5/3. You know, I'm just cheating here because I just want to get this done. 5/3 minus 2. Whoops, I forgot my minus 2. In here. What's that value? All right, 1/3. And then plug in that same thing on the right side. 2 times 5/3 minus 3. Also 1/3 equals this one works. Yes, sir.
So when there's two variable on both sides of the equation, only going to one.
Sometimes there's 2. Yes. Oh, on the calculator? Yeah. You press the math button, move 1 to the right and to the num menu, and see that first thing? That's your absolute value, and you put in whatever you like. Yep. Whoops. Oh, not you. Okay. So, all kinds of time. It's awesome. All right, so let's try this one. 3x plus 2 could be, it was the positive value. Or it could be 3x plus 2 was the negative value. You can group it when you make it negative. Solve these equations. Whoops. X equals, I can't read my own writing here. Is that negative 3? Where am I? I can't read my writing. Okay. And then this one becomes 3x plus 2. Now distribute the negative. A lot of work here. 7x
No.
equals,
No answer.
just let me finish here. X equals negative 1. Let's try x equals negative 3. Plug that in. 3 times negative 3, negative 9. Negative 9 plus 2 is negative 7. Take the absolute value.
Negative
Put
one.
the negative 3 here. 4 times negative 3, negative 12. Plus 5 is negative 7. No, does not work. Reject that guy. Let's try negative 1. 3 times negative 1 is negative 3 plus 2. That's negative 1. Take the absolute value. 4 times negative 1 is negative 4 plus 5. 1. Yay. But, Jerry, your question is it always going to mean that if the x is out here? No. Sometimes it can work. Yeah, we have time. I'm going to do G before we go anywhere. So let's do G. I'll do it down here. So it could be that 2x plus 1 is x plus 5. Or it could be that 2x plus 1 was the negative of that value when we took its absolute value. So let's solve this one. That becomes an x is 4. What happens over here? 2x plus 1, distribute the negative. Oh, that's a 3x, yes. And that's a negative 6. So x is negative 2. Now we're going to test that. So plug it back in. So if it's a 4, 2 times 4, 8 plus 1, 9? 4 plus 5, 9. Okay, this one works. That one's good. Let's try negative 2. 2 times negative 2 is negative 4. Plus 1, that's negative 3. Take the absolute value. Negative 2 plus 5, 3. Oh, they both work. Okay. Sometimes they both work. And that's okay. All right, so I think, so we've kind of finished practicing with the equations. Let's work with the inequalities. Same general idea. So it could be that x plus 2, I think, is the positive value. So you keep the inequality the same. Or it could be, well, is this an or or an and? Or x plus 2, turn the symbol the other way and negate what's on the right side there. So that's the two inequalities they need to look at. This looks like x is greater than 0, or x less than negative 4. So if this was something we wanted to graph on the number line, if that's 0 and this is negative 4, so x is bigger than 0, or it is less than negative 4. If it is one of those two things, it is a solution. So let's try the letter I. See what's going on with this one. So 2x plus 3 absolute value less than x plus 6. So it is isolated on this side, so I just say, what if that was the positive result? And that doesn't change. This is an and, less than. Or and, 2x plus 3 is greater than the negative of x plus 6. So, wow, okay. So 2x minus x is an x. Subtract that 3. It looks like x less than 3. And, gotta expand this guy a little bit. X plus 3 greater than, by distributing that negative. So, add that one here, you get a 3x. Subtract that 3 over here, you get a negative 9. So x bigger than negative 3. So x is, it's less than 3, but it's bigger than negative 3. So x is between, but does not include negative 3 and 3. If you were to graph that, it looks like this. 3's are circled but not filled in, and then everything in between. Let's try this guy here, which, put the 2 on the other side. Do that first. So 5 minus 4x is going to be less than 4. And now I have to decide, is this an and or an or? This is a less than, so it's an and. So 5 minus 4x is less than 4, and at the same time, 5 minus 4x, turn the symbol, negate what's on the right side of the equation. Solve these two things. Negative 4x less than negative 1. So x dividing by a negative, so now I turn the symbol in 1 over 4. All these things still rules apply here. And? I think that's an and. I'm looking at what I'm doing here. Okay, this side here, that goes onto this side, so negative 4x less than negative 9. Okay, and then I'm dividing again by the negative 4, so it will turn 9/4. And that should be an and. So does this make sense? Let's see. If x is less than 9/4, but it's bigger than 1/4, right? This is smaller than that. It should work. So if you're at 1/4 versus 9/4, it's getting a little messy here. We can fit them in between. A little bit hard to see this. Sorry about that, my friends. 1/4. X is between 1/4 and 9/4, but does not include those boundaries. Let me erase some of this, just so we have a little more room here. Erase that figure here. Let's see if that helps us at all. Okay, so negative 3 times this. So again, you always want to have the 2x, the absolute value all by itself. So let's divide by that negative 3 first. We get 2x. Because I'm dividing by a negative, the greater than becomes a less than, and negative 6. It would be an and situation, except absolute 2x less than negative 6. Why am I pausing here? Why don't I just keep going? Just come on, yes, 2x less than negative 6. Yeah. And 2x greater than 6. Why am I not doing that? Pause. Absolute value, a positive number will come out of here. Is a positive number ever smaller than negative 6? Oh, so I can stop right now. Phew, save some time, right? Save a little time with that. So think about it. Always kind of like, this doesn't make sense. Especially if you're seeing negatives and stuff like that. This one here is an and, right? It's a less than equal. So it could be x over 2 plus 6 less than or equal to 10. That has to be true, and x over 2 plus 6 has to be bigger than or equal to negative 10. So, well, that's little. Subtract 6, so x over 2 less than or equal to 4. Multiply both sides by 2. X less than or equal to 8. And x over 2 bigger than or equal to, I want to say negative 16? I think that's right. And then multiply both sides by 2. X is bigger than or equal to negative 32. So I put my x in the middle here like I should. The less than or equal to 8 goes here. Bigger than or equal to negative 32. Well, that makes sense. So what I've got going here, I'll put the little graph up here, is here at negative 32. That's a solution. Here at 8, that's a solution. I'm filling it in because there's an equal sign here. 8. And everything in between. Those are all the solutions to this. It's a lot, boy, there's a lot of writing here. But you're basically, you're solving these equations, you're solving inequalities, you have to think of the two cases, and then you do have to check that your solutions make sense. Those are kind of the things we are working with. So, this is all algebra. And I want to show you another way to kind of approach this that I think is helpful, because there's a lot going on here. It could have two solutions. It could have one, it could have none, it could be all real numbers, right? It could be a lot of things. So graphing to the rescue will help us. Question over there? Can we come back to that in a second? I just want to get to the next bit and I can turn it back. Okay, so I just want to review graphing absolute value. We did a little bit in the beginning of class. The little grids did not copy very well. You're going to have to do the best you can with that. But y equals absolute x. So when x is bigger than 0, it looks like y equals x. And when x is less than 0, it looks like y equals negative x. That's what absolute x looks like. And last class, we worked a little bit with the transformations. So this one in the middle, I'm near the bottom now of the page there, what transformation is going to take place here on this particular parent function? What? Somebody had done their usual suspects. What's going to happen? We did this last time. Oh, yes. Thank you, Moss, yes? To the left. So you're going to move over to the left too, and pretend now you're back at the origin. And now from here, you just graph what it looks like, right? This is what we learned last time, how to easily and quickly graph what y equals x plus 2, absolute x plus 2 looks like, using transformations. Now what's the difference between this one and this one? Krishna? What? Well, I'm not like solving an equation now because this is no number here at this point. I'm trying to graph it. So I'm trying to graph the transformations. This is like thinking back from last class. So when I had it, if I add 2 to the x value, it shifts it less. This is the whole function I'm adding to. What does that do? Remember Rohit? It does. Right? If you're adding it to the function, it goes up to. If you're adding it like to the y value, if you're adding to the x value, it goes up. It goes left. Right? So I'm just going to take my absolute value x and shift it up to. And then from here, pretend you're back at 0, 0, and just graph the y equals x from here. So we do have to be very familiar with those transformations because we want to be able to graph these quickly, not having to think too hard. And now I'll tell you why we have to do that. Because the bottom here, we're actually going to solve absolute value equations by graphing them. What? How do you graph them? So the idea here is make this a separate graph, y equals absolute x, and then make this a separate graph, y equals 4. You're going to graph both these things separately. So y equals x, and again, I know they're a little hard to see. The code grids did not come out well, so I'm going to do the best I can here. But I'm graphing y equals x, or absolute x rather. Okay, that's this graph. What does the graph of y equals 4 look like? What does that look like? Yes, sir?
It's a straight line from 4 and -4.
Straight line from 4 to -4. What do you mean? Like here?
No, in the straight
What kind of line? I know it's a straight line. They're all straight lines.
Vertical.
Vertical? Close? What is it? This is the horizontal line. I want to know where on the plane are all the y's equal to 4? No, over here, right? Whoops. These are all the xy pairs that have a y of 4. And so what you do now is, remember when we did systems? You said, what's the solution? Where is the solution? At the intersection. So I've got 2 intersections here. This one is at 4. And this one is at -4. Isn't that the solution to this? We know what the solution is, right? That's an easy one. So if you can find where these things intersect, then you can solve the equation. And it's a very visual way. Can I see that there are 2 solutions? You bet. You can use your calculator to help you with this as well. Actually, I'll do that on a different one. I did for one of this last class. I want to see what's in here. Nope, not you. Okay, yeah. So this one here is y equals absolute x. That's this. And this one here is y equals 4. So put this one in y1, put this one in y2, and then you graph it. If you forgot where absolute is, you press math, and you move over 1 to num. It's the first choice there, so you can get it that way. When I graph it, there it is, right? That's my picture. And then if you press the second button and then that second calc, see the trace button, second, and you press that button right here, see where it says intersect? So that's number 5. And it's going to say first curve, and if you move these a little bit, I can see where I am. I'm on this line right here, closest to this intersection. Hit enter. It will do its best to find the second curve, and it did, which is this line. Hit enter. When it says yes, hit enter. X is number 4. And then you can do it for the other one as well. You would just repeat that. This time, though, I want to get closer to the other intersection. I just kind of move it over there. So this is a way of either checking your solution, or just finding it all together. So 4. So it is using the graphing method, but let's do it again by hand. X minus 8. Absolute x minus 8 is 2. What transformation? Because one of them you're going to graph as y equals x minus 8. What does that look like? What's the transformation? I'm a little worried that there's only 2 people who get this at this point here. What's the transformation if x, add or subtract something from the input? What happens? You shift it right 8. So this is the one that feels backwards. And then, okay. So I go 8, 1, 2, wow, it's hard to see it. Let me see. 1, 2, 3, I think it's here. I cannot see. 1, 2, 3, 4, 6, 7, 8. Maybe it's this one? I hope it's right. and then I graph what y equals x looks like from here. And then I graph y equals 2, which is over here. I'm a little trouble with my slate here. Okay, y equals 2. That did not come out well, but I look here and I look here. Looks like a 10. I think that's a 6. And that is the solutions. We know how to kind of solve it, plug it in. 6 minus 8 is negative 2, absolute value. 10 minus 8, 2. Looking at where they intersect. These are U tries. The only thing is I want to actually do this one. I want to do that last U try. Because our graphing's not so good. So I have to graph y equals x minus 1 plus 5. What are the transformations taking place on my parent function of absolute x? There are two things happening. Anybody able to name them? Suspects. Nobody else? I'm just worried that you guys aren't getting this. Madison, help me out here.
Move it over to the right one and up 5.
Yes. Excellent. So I'm going to go graph this thing. You move over 1, then you count up 5. 1, 2, 3, 4, 5. So this is, you just draw y equals x from here. And then you graph y equals 3. Hang on. 1, 2, 3, and that's that horizontal line here. So Jerry, what is my solution? Nothing. There's no intersection. So if you are unclear, I don't know, does this thing have a solution? Doesn't it? I don't know. You can put this in your calculator and look. Look at that. It's very visual. It's a very nice way if you're a little confused with how come it has one, how come it doesn't. This is actually what's happening. Yes, sir.
And also you can just like put 5 into 3 and that would be negative. So
You could if you wanted, but even if you just don't, I won't change anything. What if I make a mistake with the math, right? So which, I would do that. 3 minus 5, I would get there wrong. So you can just leave it the way it is. Now, algebraically, totally agree you need to do that for the algebra. Try this one. Yes, sir?
Would the negative absolute value of x be upside down?
Yes, if you put a negative in front, it inverts it. Yep, you get a reflection. Try this one. You know what this one should be algebraically, right? When does x minus 3 equal 5? When x equals 8. And when does x minus 3 equal negative 5? When x equals negative 2. So just try that one. Graphically, you should get the negative 2 and the 8, and there shouldn't be any problem there.